So we're really happy to be here. Actually,
we could ask to get a 16:9 format, which we were asked to do the presentation in.
Anyway, let's get the slides up at least. There we are. Yeah. So we're going to talk about personalized e-commerce really fast in 40 milliseconds. I'm Magnus Nordlander. You may recognize my sultry voice from the Sound of Symphony podcast. Just doing a little bus marketing. And this is Patrick Willin.
Hi, everyone. I'm a lead developer for Gymgrosystem. I'm going to present it in just a second. I'm also the architect of the project, which we are going to tell you a bit of a story about today. Our personalized e-commerce, how we've managed it. To start off, I thought I'd present the company and give you a bit of an idea about the scope. The company is internationally usually called HSN Health and Sport Nutrition Group because Gymgrosystem just doesn't really work that well internationally. We are the third largest sport nutrition retailer in the world, but we're also part of a group called Qliro Group. Now, Qliro Group is the largest e-commerce company in Scandinavia. If you're from that part of the world, you might have heard of brands like cdon.com, Lekmer, Nelly, which I think France has heard of as well, and a few others. We gross, I can't even remember how much revenue the group has. But Gymgrosystem has an annual revenue online, I might add, all online, of 90 million euros. We see roughly 20 million sessions a year. So we do have quite a big load, especially peak hours, like just the other week with Black Friday. And we see about 1 million orders a year. So that puts a big stress on our servers, obviously, because e-commerce systems isn't traditionally the most lightweight. Magnus?
Yeah. So I'm from Ferve, which is a much smaller company. We're basically 2 people. And we're a small Symfony consultancy, so we're specialized in Symfony. And we're in Stockholm. I don't have a very long description about it. If you're interested, you can just go ahead and talk to me. I'm always happy to talk about Ferve. Or you can just read our webpage at fervo.se. And another way, actually, to ask me about Ferve would be to do that during our question segment of this talk. We realized that it's going to be sort of difficult to actually take questions from the audience here, so we came up with a great idea of you getting to tweet questions at us using the tag HSNGQA. And if you are having trouble remembering the tag, it's on your schedule. It's in the title of the talk, and then just Q&A for Q&A. So feel free to ask any question, no matter how ridiculous. It doesn't even have to be about the talk, although we'd prefer it to be. Like, how tall am I? Why is the Ferve logo a flame? That's perfectly fine questions as well.
Could you ask a question? What question to ask?
Yes, that's a perfectly fine question as well. Any questions are fine. We might not answer the. Well, we'll have to make a decision when it comes to answering them.
So, this whole process started around 3 years ago. We had management decisions saying that we were going to personalize everything. Well, basically to increase our conversion rate. We couldn't actually do that on the platform we were on and still are on, partly. That platform has been continuously developed since 2001 on the same code base. Well, it's pretty old, to say the least. We didn't really have the performance in it. We've made vast improvements with the performance since, but it's still not there. We can't take it all the way, unfortunately, and we can't implement personalization the way we could. And being the generation it is, and it hasn't actually gone through a refactoring in all that time, well, it's sort of a technical dead end, and we've reached the technical peak of that platform, where we're seeing deadlocks in the database, and we just can't do much about it, unfortunately. So we decided to go to Magento, which was before my time, actually, but to migrate everything to Magento, which we have begun doing, but we aren't really seeing the performance there. We have implemented the personalization, and as a result, we can't use well, any caching and the full page cache. So we are suffering performance-wise. And we are seeing some fair stability there, which is nice.
Hey, Patrick, you're talking a lot about personalization.
Oh, I am going to...
Does everyone really know what personalization means in this context?
I thought I'd do that in a bit.
Really? Okay.
Yeah.
Well, I thought it would... Okay. Go ahead.
Thank you. So, this is what we have. We have more, but this is the key factors of our setup. We use Magento Enterprise, and we're running it on CentOS and Apache with MySQL, Redis, OpenCache, and Aptos eCells. Now, this is quite good personalization engine. It's not a segmentation engine. It's a true personalization engine. If you see a product listing, it will personalize that for you based on your previous preferences, your view patterns, your purchase patterns. Have you put something in the cart? Have you actually checked something out previously? You might actually try to find something similar, or depending on what sort of connections we've done between products, you might actually try to offer you something complementary to that product. But if it fails to actually attract attention to this, it will try to shift. It will try to put new products in front of you going to the same page. So at any given time, we might get different results from the same page.
I think you skipped a couple of parts there.
Oh, sorry. Yeah. I skipped your parts.
Well, and some of your parts as well. So actually the reason that we at Ferve got brought into this project is we were developing an inspiration site, which is basically editorial content regarding nutrition and training and, well, basically anything within the business area of Human Assistant. So that's one of the platforms that we developed. It's based on Symfony 2. We're using Doctrine. We're also using one of my personal favorite libraries in the ecosystem, which is SimpleBus. So that's definitely something to ask questions about for the Twitter feed. And we're using Fly System for handling images and any sort of files, really. It also uses eCells. In this case, it's using it more as a search engine, because anything which is applicable to really finding products is also equally applicable to finding articles or blog entries. And we're using MySQL to store data in a database, which is not that exciting.
Yeah, might add that we also use the personalization engine to register what a user is actually looking on the inspiration side to actually gain traction on the e-commerce side. So we gather some data on the user's preferences, so we can use that data to give product results when searching and listing, etc. And also, a big part of our setup is our CDN, Akamai. We are using Aqua Ion Premium, which is one of the more expensive products, to put it bluntly. We also have something called Dynamic Content Assembly, which is basically, funny enough, Akamai renaming ESI. It's their own technology, and they've renamed it in their service. Don't ask me why. We do have web application firewall there as well, which helps us keep our applications secure. And we do have fast DNS. All our DNS services are actually register pointed to Akamai, which is quite fun. I once lowered the TTL to, I was going to Akamai's one of the domains we had. So I loaded the TTL as per instructions. So I loaded it to 5 minutes. I thought it was pretty low. So I speak to my Akamai representative and says, "Are you sure you want it that high?" I said, "Well, yeah, it's 5 minutes." "Yeah, that's high." "Okay, so what's low then?" "Well, 20 seconds. Go for it." That's the sort of capacity they have, and which is quite nice. And at any given day, when you actually look up say a Facebook, for instance, you always get to Akamai, because most of the major companies are running them, probably except Amazon, I think. Yeah. I don't actually think they use it. But they usually have a TTL of 20 milliseconds as well, which is fun. Now, so, what happened?
This would have been more fun with the scale, actually.
Yeah, could we actually get...
Actually, I think, let me try.
Do try.
There, now you can see the scale.
Oh, how about that?
I'll simply hold it here for this part.
For the duration of the presentation, yes, thank you very much. So, I mean, looking at this New Relic graph, we were not really seeing the performance we want. I might add that this is not even the worst of it. This is all requests included, so we're talking fairly lightweight AJAX requests as well, which gives us an average of roughly 1 second, which isn't really what I'm happy with. But that's a result of us not being able to cache. And the application in itself has a very, very high overhead. It's an old-fashioned system that's really, well, heavy. As you can see, we're not really stable in our response times. A lot is going on here. We really, I mean, we have a shift of about 400 milliseconds, which is way too much. At the end, we were just delivering a quite slow site, which isn't really that pleasing to the user. And I wouldn't say worse, but it does become a very serious problem, because we are spending so much server resources, it gets expensive. So in numbers, that's, well, as you can see, we get roughly 1 second average response time. Part of the explanation for that is we have part of the cache. We do cache some bits, template coding, etc., in Redis, but we have to make 143 Redis calls to do that. Given that it only takes 0.5 milliseconds to do it, it's still 143 round trips to do it. We reached the peak at around 800 requests per minute on each server due to the slow generation time. And we were, no surprise there, we were roughly about 500% of the budget in terms of operation cost due to this. So that's a bit of an issue. Excuse me. So, personalized e-commerce. Can you cache it? Well, most say, and most have said, that it is impossible trying to do what we're trying to do. I hate saying something is impossible. You can always find a way somewhere. But let's look at why this is so hard. Magento, for instance, ships with the source document on every request, basically in itself rendering anything uncacheable outside of the application itself. If you would actually cache it, you can do it, of course. You can cache it, just adding a session and hashing the content of the cart, binding that to each hash key, and you'll have an offload of 0. But what we can do to mitigate this problem is do this asynchronously by Ajax. It has been done for quite a long time in e-commerce, but what we started to do is actually caching it very hard in local storage, and actually loading it on the fly in the document from local storage, injecting it directly in the DOM. So we always load an empty cart with the source document to make the document cacheable. And we always load it from local storage, and all operations actually manipulating the card needs to go to the front-end controller doing this to invalidate the cache, because we don't actually Ajax every request. We only Ajax when we've invalidated the cache to further reduce the server load. The page header is a classic example of something that is cacheable. I mean, it's fairly static, but it's also something that's central, so you should try to lift that out and use a central resource for it. We use this by using ESI. How many of you actually heard of ESI in here? Quite a few. How many of you actually worked with it? Quite a few less. Yeah. ESI is an Akamai technology, which basically is an let's call it an XML tag you put in the document with a source tag pointing to an endpoint where you find that part of the document. So you basically split your document up.
One might call it an edge-side Ajax.
Well, pretty much, yeah. It does the same thing as when you Ajax, but you do it in your CDN, not actually delegating it to the client to do this. And there's relevance to do that in terms of very important data that Google might want to have, or you might not actually want to change those parts of the document for the user's sake. Same thing with category data, but that's completely cacheable. We don't change it on a personal basis. And in this case, we are on a category page. And this is actually the data associated with the route we're on. So that data should be cached with the base request. The cache key of that data should be tied in with its routing. So we cache that with the base request. And then we get to the funny bits. This listing, if you browse around for a while, you purchase a few things, you're not going to get the same result as I am going to get. And the next time you visit, if you didn't click anything, chances are you might actually get something else as well. And to make it worse, to confirm the personalization data, the personalization engine on occasion tosses in the odd thing it doesn't expect you to click first. Just to confirm you don't really like that sort of thing. So it just tosses that in somewhere quite early to just confirm that its data is correct. The pagination then. Well, it doesn't really change between persons. There's always a set amount of products in a category. So that's cacheable and cacheable with a base request. Product collection. Now, this is uncacheable, completely uncacheable. Changes all the time. We've gone through that. How about the product data then? And this is one of the heaviest. If you've done e-commerce, you know that this is probably the heaviest operation you do, listing, say, 40 products on a category page, because you load such a big part of the product data. You need to initialize the classes and read through the databases. It doesn't get much heavier than this. And that, well, I mean, the data don't really change. We don't change the name, image, etc. So in theory, we can cache that somehow. And just to make things worse, we obviously have a very good marketing department who loves making price groups and having retailers that has their own prices, obviously. So that more or less just breaks the cacheability of the data, because you're mixing in another layer of complexity. You could segment it, but then you're gonna have a vastly lower offload if you start segmenting on each price group. So what we've done is decided to just take the normal price, the normal campaign price and the normal price. Let's cache that. We can cache that. And let's Ajax the special prices. Because where do we make money? It's not people who's got lower prices, etc. And if we're going to start segmenting the cache, they're going to have to wait for the result anyway, because it's going to be uncached if we manage to cache it. So we might as well just cache the normal thing and Ajax the little data we need, just to keep our cache rates up. But as a result, this HTML document is quite uncacheable as a whole. Now, that's mostly due to the fact that we view a page and a document in this way as the end result. We fail to take in perspective of time and multiple platforms and multiple layers. Looking at a page more like this, well, I don't actually envision pages like this, but I tried to do it in Photoshop the way I envisioned it, and let's just say that I shouldn't pursue a career of graphical design. But what we want to do here to make this cacheable is get rid of these products from the base request, right? Everything underneath here is now cacheable. So how can we achieve this? Well, again, using ESI, we can put a single ESI request per product listing out from Magento to another application which is running live, which we don't cache, talking to our personalization engine, asking which product should we show, and in turn actually generating ESI tags back to Magento for each and every product block, and caching each of them individually, and actually delegating to the cloud to have the server capacity to assemble this as well. Magnus?
Mm-hmm. I actually want to point something out specifically regarding this page. So what we're actually able to cache is each and every one of these products separately. And to do that, we've built a small application. I like to think that we're using a naming convention of DC themes. Patrick does not agree.
I do not.
But that's what it's been so far. So we've called it the Cosmic Treadmill. Anyone who knows The Flash perhaps have heard about the Cosmic Treadmill. I'm actually going to stand here if you don't mind. So basically, Cosmic Treadmill is a Symfony project, but it's a very lightweight Symfony project. So what we've done is that we've taken, we started with the standard edition actually, and then we started to remove things that we did not need. And it turns out that out of the standard bundles that come along, all we really needed was Framework Bundle and Twig Bundle. Of course, we have our own code, so that's a third bundle, but out of the standard edition, we're not keeping Doctrine, we're not keeping Monologue, we're not keeping SwiftMailer or anything like that. So we stripped down all the bundles, but there's actually more things you can do to make Symfony run faster, and that is, if you're not using them, you can just go ahead and disable some functionality in Framework Bundle, like forms, like validation, like translation, or the session. In our case, it would be actually totally impossible to use sessions at all, because that would make the response uncacheable, and that's completely contrary to what we're trying to do. And some might ask, why not just go ahead and use Silex? I mean, Silex is fast and small, and sure, we could have gone ahead and used Silex, although why would we? I mean, this is performant enough, as you will see later in the presentation, and Symfony brings along with it a lot of structure, which I really like, so let's just use Symfony. So what did we do? So what we did is basically an application that talks to the personalization server via an API, and then it talks, or sort of talks, it knows the addresses of like product fragments and other kinds of interesting fragments. So basically what we've done is we've made a bridge in a Symfony application between the personalization engine and ESI. So you can talk to the personalization engine via ESI, which is pretty cool. So part of being able to do this is to make cache fragments that make sense. So I'm going to talk a little bit about that. So step one, really, in order to make a good cache fragment is to make sure that it's only, we actually don't know if there's a better word for this, so we came up with one. It's cache principal. It's really the object that is the main object for the URL. So if you have a product URL showing a product, the product is the cache principal. And you should only have one of these per fragment. It might make, it might be obvious, but if you don't, you're going to be clearing too much cache, and that's sort of contrary to what we're trying to do here. We're trying to keep as much in cache as possible, not clearing it all the time. So there are some exceptions, obviously. Like if you don't care about stale data, you can definitely keep it in the same fragment. Or if it always updates together, you can also keep it in the same fragment. That's fine. But otherwise, really, there should only be one. If it isn't able to be in the same fragment, you should just put it out on a separate ESI subrequest, because those are separately cacheable. And another big part of the strategy for this application is to use cache invalidation, because like I said, we want to keep everything in cache for as long as possible, and as much of the application in cache as possible. So whenever we're editing anything, we're using cache invalidation to remove things from the cache. And a great way to do this is to use a tagging cache. And most caches, like Akamai and Varnish, aren't tagging natively. I know that there's a fancy bundle for Varnish called FOS Cache Bundle, which I believe is a session tomorrow, so I'm definitely going to be checking that out. That makes Varnish tagging cache, which is awesome. And regardless, it's easy to handle cache tagging on server side. Basically, you just, whenever you're using an object on a cached page, you store the URL and the cache tag in a database. It's never going to be an issue that there's a page in the cache which isn't in your cache tag database, because in that case, how did it get into the cache? I mean, it has to be generated server-side, so it's always there. Whenever you want to just clear out the old objects, you simply remove all the cached URLs. It's a simple purge request usually. There's some limitations, and they depend on which platform you're using. If you're using Akamai, there's only 64 available subrequests. If you're using Varnish, you can't do simultaneous subrequests. If you're going for an open source solution, I think Apache Traffic Server is a good choice, because that doesn't have the multiple connection limitation. I don't know if it has a number of fragments limitation, but it has generally pretty good ESI support. That's definitely something to be aware of, that you may have limitations. And all of these servers actually treat ESI a little bit differently, like how you're specifying your downstream TTLs, or your pretty much anything is treated slightly differently. So they're not really compatible with each other. The basic syntax is still there, but there's always slight quirks with each of them. So do be aware of that and read the documentation for whichever edge cache you're using. But I guess you probably want to see some results, right? Right? Yeah, for sure.
Yeah. Well, to give results a perspective, we might also I might share what my CTO wanted from me. We had like 1 second, right? Which isn't entirely true because the category page averaged at 1.75 and a product page at 1.89 seconds, I think. So the pages we're actually affecting here are far worse, and what we're keeping are you know, the far faster requests. But he told me that we should deliver this time to first byte in 100 milliseconds, and we should have an interactable site within 1 second. So I said, yeah, okay. That's why I'm interested in building this application to Magnus. So how did he perform? How did he do? This is production data of part of this solution that's running now. We are due to putting the entire solution live very shortly, but it's a bit of a challenge doing all the bits and getting everything in order, especially in validation.
This is PHP 5, by the way.
Yeah, this is
not PHP 7.
Yeah, this is PHP 5. So we do see Cosmic Treadmill performing PHP time under 20 milliseconds in average, which is pretty nice. And the network time, you see, that's connecting to e-sales. We can't do much about it. It is very fast. It's very fast in its execution time, which is one of the true benefits. Also, we might add to the numbers that Akamai has an overhead of about 8 milliseconds to actually initiate and pass the document for ESI. So they say that there's a ceiling of 8 milliseconds in that. And obviously we have some latency going from the edge server in Akamai down to our servers, collecting this data and then getting that data back. So that's why we didn't actually put the target on. The target I had was 100 milliseconds, but Magnus had a target about 40 milliseconds to actually make way for all these other results. But in terms of what we get out of this, we are seeing some drastic differences in most types of pages. The average is obviously quite lower because we're affecting most sites. I'm not going to go through the numbers individually. You can look at them yourselves. But generally speaking, we are nearly on budget in terms of our operational costs with this solution. We have a quite fast return of investment on it as well, which is quite nice. So, what have we been talking about? And what did we achieve?
Just go ahead and show the scale again here.
Oh yeah, it's the same scale though.
Yes.
But we are seeing, below 200 milliseconds average response times if we're looking at the entire picture, because we are removing so many parts from actual Magento generation and delivering that from Akamai caching. What we need to load the servers are roughly under 50 milliseconds. You can see the graph, it's quite more stable here than it was for the previous graph, which was more or less a roller coaster. Well, obviously, delivering something fast has a quite big brand impact, or rather, you don't negatively impact your brand perception by having a lousy, slow-ass site, which, at least in theory, should lead to an increased conversion rates, and an increase of request capacity per each server is obviously very much a cost efficiency thing, and e-commerce is mostly about cost efficiency to actually make money. So we get quite low operating costs. And we only load the server when we need to. We we load the server where we actually make money. We load the server when we add things to cart, when we go to the checkout, when we deal with personalization. With practically all integrations parts, we obviously integrate with the server, but we can deal with that. If enough people add things to the cart, we need to increase our server capacity, but we'd love to. I mean, more people are buying our stuff. That's great. So that's no problem. And that's pretty much it for us.
Yeah.
Thank you for listening.
Let's see if we have any questions.
Say again?
Let's see if we have any questions.
Yeah, let's see if we can administer any questions and do have any questions.
What size hat are you wearing? No, that's... When's the next podcast? We're actually recording on Saturday.
What's the next movie you're going to see?
The what now?
What's the next movie you're going to see?
That's a good question. That's probably some Marvel movie. Let's check out the questions.
Oh, what's up with the red lines on the graph? That's a very good question. Maybe you should just bring that up again.
Not that one. I'm pretty sure it's the on this one. Those lines.
That one.
Yes.
Yeah.
Three?
One second.
Oh yeah.
There we go. That's deployments. So I think it is actually. I think that's deployment times.
I'm fairly sure it is as well.
Yeah. So at some point, Magnus did something good with this application then. Yeah. Next question.
What? Okay. So this is the last question.
Yeah.
Let's pick one. Let's not pick the one how tall I am. 6'7", but let's pick a better question.
What is
That's a good one.
Yeah. What's the time for a request for which the cache has been invalidated and you have to create the page? That's a very good question. Right now, it's roughly between 2 and 4 minutes between we make the API call to Akamai and it's invalidated. However, we are also in a beta program with Akamai for their instant cache.
That's not what I don't think that was the question was about. I think when the cache is entirely empty.
Oh.
What's the loading time? And no, it's not 2 to 4 minutes. It's not fast, but it's not 2 to 4 minutes.
Actually, I mean, obviously, we are loading Magento twice then. We are loading it in 2 sequences, even if we're doing it parallel.
Yeah.
We are roughly seeing 120% of the original load time when we completely uncached. So we're not completely destroying the user experience. However, we are shooting ourselves in the foot, considering we are actually on a category page with 40 products, generating roughly 50 requests simultaneously to Magento. But then again, we're caching it up, so it's going to be quite brief. And but you do have to be careful with cache invalidation, because yes, if you run this uncached, you are going to shoot yourself in the foot.
Yeah, this does not happen very often. I mean, most objects are in the cache, and I mean, we don't do big sweeping invalidations, because that would, like I said, it would be totally contrary to what we're trying to achieve here, which is to have everything in cache. So it's very rare that nothing's cached on the page.
All right, thank you very much.